Yeah, and also I need to plug in my laptop too in a sec here. Okay, so factoring is just a way to break apart a number or an expression into smaller parts. It's advantageous for algebra or for expressions because when you do start dealing with like more advanced topics like pre-calculus and calculus, it'll make those problems more efficient if you
Mm-hmm.
can factor them. So it's just a skill that we want to make sure it's very solid. So when you move forward in math, that you have these, you can go about problems more efficiently. But otherwise,
Yeah.
math people just top out after this
Hmm.
class. They don't learn back, and then they can't do these other skills, right? So
Yeah.
that's why we have it. So, but give me one
Yeah.
sec. Let me plug my laptop. Hold on. Okay. So there's some techniques for factoring. One technique is just to find what's common among all the things being added and subtracted. Like say AB plus
Hmm.
AC, put A as common so we can pull it out.
Yeah.
Or here, A squared is common because A squared is a factor of A cubed.
Hmm.
And of course, anything is a factor of itself. Um, Now it says here, talk to yourself. I don't know what's meant by that, but sometimes the factor can be pretty simple. Like you just see, okay, well, sure, x and x multiplies x squared. Um, Whatever multiplies to c and adds up to b, we can break that apart.
Hmm.
There's always different things that happen. Um, Magic, I'm not sure what that's meant. It's meant by that.
Um. Oh, it's like my teacher's like one of his methods.
Okay. Well, I'm going to show you some methods myself so you have some techniques you can use. Definitely there's something called perfect squares where if you take two things being added together and square it, it gets you this.
Yeah.
Or if you square this, you get this. So because if you were to multiply a plus b with itself,
Hmm.
a and a is a squared, then
Hmm.
ab plus ab plus b squared. So that's why that makes sense. If you put a minus instead of plus, you get the negative 2ab.
Hmm.
Where's another one you can see? Um, for example, if you have like x squared minus 4, that can be expressed as x minus 2 times x plus 2. And
Hmm.
that's because if I FOIL it, x times x is x squared. Then you get positive 2x, negative 2x.
Yeah.
And then you get negative 4 when you do negative 2 times 2.
Hmm.
The middles cancel, leaving with x squared minus 4. So whenever the
Hmm.
first and last terms are both perfect squares, there's a minus in the middle, we totally can just factor that way.
Hmm.
And then there are some other techniques like factor grouping some different cubes, which, yeah, we could do that, but I got another technique you might like a little better. Okay. We'll come back to 1 and 2 in a moment. I really want to focus on three, four,
Yeah.
5, 6. Those are good ones to really focus on.
Yeah. The
But
ones
here, good.
hold on. I mean, just the ones that we struggled, like the whole class struggled with. I just really didn't understand.
Mhm.
7 and 8. But I
We'll get
guess
to that also. Yeah, those are tougher also, but here's a technique you can use because I'm going to use this technique for seven
yeah.
and eight afterwards. Now, sometimes yes, you could do trial and error. You could just kind
Yeah.
of see it, like okay, what multiplies to 60 and adds up to negative 17. So that's really what you're doing. I'm putting 60 up here and negative 17 down below. I call it the AC method because in general, a quadratic equation looks like this, or a quadratic expression looks like this. There's a number in front of x squared, there's a constant, and there's a middle term. So I put a times c up top and b down below. So what two numbers multiply to the top but add to the bottom? So, there's only so many possibilities. 1 in 60.
Oh, yeah.
What do you think? You got
Um,
something?
that it adds up to 60. Hold on.
No, multiply 60. So
Eight?
right.
No.
Well, hold on. You always do one in itself because that's always going to be a guarantee that will be a possibility. But of course, that's of the 61, not 17.
Mm.
2 and
I
30
got it, I got it, I
multiplies
got it, I
60.
got it, I got it, I got it, I got
Go
it.
ahead. Go ahead. Tell me.
9 and 7.
Well, nine
No,
times 7 is
no,
63.
no, that's one more. That's one less.
Okay, those are going in order. 1 and 60, 2 and 30, 3 and 20, 4 and 15. So I'm slowly increasing this number here. And I'm getting warmer because 4 plus 15 is 19.
Yeah.
What about 5 and what? What's 60 divided by 5?
Um, 60 divided by 5.
Use a calculator. You don't have to in your head, by the way. Use a calculator, by all means.
Yeah, I don't understand this real quick. 60 divided by 5.
You use your phone if you need
Oh,
to,
it's
or a
12.
calculator.
It's 12 and 5. That equals
You're good.
7.
Good. And do those two numbers add up to 17?
Mm-hmm.
They do. But because it's negative 17, I make both of them negative. And that's okay, because negative 5 times negative 12 is 60. Now, because the first term had a coefficient of 1, then you can just go straight to the factor form.
Mm-hmm.
Because if you FOIL, meaning multiply first, outside, inside last terms,
Mm-hmm.
you'll get back to the original expression.
Yeah.
Um, Now another thing you could do as well, it's a little redundant, but we'll definitely need for 7 and 8.
Mm-hmm.
I do something called maybe what you teach me is by magic. You can do a box where you put the first term the upper left corner and the constant in the lower right corner. So last one lower right corner. And then these two go in the other two corners. Doesn't
Mm-hmm.
matter which one exactly. Because what you're doing is that you split the middle term. Negative 17 got split, and then negative 12 and negative 15.
Yeah.
Sorry, negative 5, negative 12. Then of course you ask yourself, well, what multiplies a squared? A and a. So put a and a in the outsides. And then that has to be a negative 5, because a times negative 5 is negative 5a. This has to be a negative 12, because a and negative 12 is negative 12a, negative 5, negative 12 is 60, because these converge over here as well. So it's a minus 5, a minus 12 still.
Mm-hmm.
So now let's take a look at, let's just go for a bit of contrast. See, I have 27 and 12.
Mm-hmm.
Now, what two numbers are going to multiply 27 out to 12?
9 and 3.
Perfect, done. So it's y plus 3, y plus 9. Okay, well, might run into a problem here.
Mm-hmm.
No, we'll be okay. We'll be okay. I'm tripping. Okay, so your product is negative. So you have one that has to be negative, one has to be positive. So you do negative 1 and 32. That's
Mm-hmm.
no good. But if I do negative 2 and 16, that's at the 14. I want to have the negative 14, so we'll just switch the signs. Make 2 positive, 16 negative.
Mm-hmm.
So n plus 2,
Yeah.
n minus 16. Okay, same thing here.
Mm-hmm.
So it's just a little bit of trial and error, but you're being methodical.
Mm-hmm.
Okay, so we'll start with negative 1 and 40. No good. What's the next pair I should try?
1 and 40.
Negative 2 and 20, getting closer, right?
Negative 4 and 4 or 10.
Good. Negative 4 and 10. There you go.
And 8 and 5.
But we already hit it with
Oh
negative 4
yeah,
and 10.
yeah,
And because you want to add to 6, which we do.
yeah. Yeah.
Now, if it was -6 in the middle, then fine, make it 4 and -10. Whoop-de-doo, right? It's not a big deal.
Yeah.
So what you will need to do is you'll need to just practice this like crazy, just over and over and over and over and over again. Okay,
Hmm.
now we get to something a little funny. 4x squared minus 6x minus 9. Now, fortunately, these are both perfect squares. So you could use the perfect square thing. Before I do that, I still want to use this technique, and I'll show you how we use perfect squares. So you do 4 times -9, which is
Hmm.
-36. Okay, actually, no, this won't work as well as I thought it would. So even though 4 and 9 are perfect squares, it's not going to quite work the way I thought it would. Plus, it's a
Hmm.
-9. Um,
Yeah.
so let's look at the options. -1 and 36. What does that add up to?
-4 and 36, -30, I mean, pause at 32.
Hold on. What's -1 plus 36?
35.
Right, that's no good. How about
Yeah.
-2 and 18?
16.
So we'll make it 2 and -18.
Yeah.
However, because the leading term is 4, we can't just say, like some people say, oh, it's x plus 2x minus 18, because that's what we did in the previous problems.
Hmm.
But what doesn't make sense because x and x is x squared, not 4x squared. So what we're going to
Hmm.
do is make this box. So 4x squared -9, right?
Yeah.
You put the first term in one corner, the last term in another corner. And the other two terms that split, because you split -16 to these two numbers here.
Yeah.
Now, if you think about it, I'll probably put a 2x and a 2x. That's because 4x squared and 2x have 2x in common. And 2x
Hmm.
times 2x is 4x squared. So this
Yeah.
has to be 1, because 2x and 1 gets me 2x. This has to be -9, and that makes sense. And I got
Yeah.
2x plus 1.
Hmm.
So what I'm doing is I'm taking away a lot of the guesswork by doing it this way.
Yeah.
This is the way I actually teach it to all my students.
Hmm.
Um, and if you FOIL it, you do get 4x squared. You do get -18x. You do get positive 2x. And you do get -9. And then you clean up the middle, you get -16x. Okay, so let's do this again. Okay, what's 2 times 7?
14.
And the middle term is 15. Okay, give me two numbers that multiply to 14 and add to 15.
Uh, multiply to 14.
Always
14
start
and
with
1. 14 and
yeah,
1.
one is cell. Always start there and then slowly increase one and decrease the other until you get to the middle. And by the way, if none of them work, then fine. It's not factorable. That could happen too.
Wait, so if nothing works, like
It's
it's
just
just one.
done. It's just say it's prime. It's done. It's not factorable. You leave it
Yeah.
alone. It just can't be done. If you want to exhaust all possibilities.
Hmm.
Okay, so 2. Okay, so if I think about it, K is common between these two, so I'll put a K up top. So this has to be a 2K. This has to be a 7. This has to be a 1. There we go.
Hmm.
Now let's look at some more here. 9, 10. Now this one does is a perfect square because you have x squared and 36.
Hmm.
X minus 6, x minus 6.
Hmm.
And it works because you FOIL it.
Yeah.
So you have that option, you just square root the first and last terms, and if it's a
Hmm.
minus, put a minus in the middle. And it all works itself out just fine because you get x squared, negative 6x, negative 6x plus 36.
Hmm.
Now here, when there's a minus in the middle,
Hmm.
you're allowed to do that. You switch the signs up because you get negative 12x, when you do negative 4 3x, you get positive 12x, you do 3x to 4. Those will cancel. Leaving with
Yeah.
9x squared minus 16.
Hmm.
Now we get to solving. Now, yeah, you do want to factor it. The a equals 0 or a equals 2. That's good.
Hmm.
Before I do 12, that's kind of crazy. Let's take a look at 13. Yeah, you want to get everything on one side first, just like we did in 11.
Hmm.
Because when you do that, you do something called the zero product property. So what's happening here, well, you demonstrate, but you've got to be a little more intentional about it or be more present to it. It's called the zero product property.
Uh-huh.
What you're doing is you're saying that I got 4a times a minus 2. One of those two things has to be 0, right? Because anything times 0 is 0.
Yep.
So 0 times whatever or whatever times 0 is 0. So
Yeah,
either
it's kind of
4a is
it's
0,
repetitive, but I
yeah,
mean,
or a minus 2 is 0. So one of those two things has to be true.
yeah.
So in this case, have x squared plus 2x minus 8. Now, once you get really good at this, you could just sort of just do it. You don't have to do the whole diamond box thing, but I know it's gonna be 4 and negative 2. But you're not out of the woods yet because x plus 4 times x minus 2. So if I write this in the text box, you understand conceptually what's happening. The value of x plus 4 times the value of x minus 2 will equal 0.
Yeah.
Hence, either x plus 4 or x minus 2 must equal 0. And so that's why you get negative 4, 2 is your answer. Look at that. Okay, so you do A times C,
Yeah.
which is 40, and you put B in the bottom there.
Yeah.
What two numbers multiply to 40 and add to 22?
20 and 2.
Good, yeah, awesome. But we gotta do this. And then that's X, that's 5X, that's 4, and that's 2.
Yeah.
So there you go. Because if X is -4, it makes this 0.
Yeah.
If X is -2 makes that 0.
Mm-hmm.
Okay, let's keep going here. Okay, so we're gonna sometimes you can just see it, but I want to be consistent here. So A times C is 3, B is
Mm-hmm.
4. What multiplies to 3 and adds up to 4?
3 and 1.
Good. That's easy, right? Yeah,
Yeah.
good. But we're gonna do this little box. Whenever the first term is a coefficient of not 1, we'll do it this way.
Mm.
That's 3x. That's x. That's 1.
Mm-hmm.
When you solve each one, you get -1, -1/3.
Yeah.
Okay, with the home stretch here.
So last problem is 18. Yeah.
Yeah. Okay, so we do that. Let's get everything on one side. And then fortunately, 64 and x squared are perfect squares, so we can just do it more easily like this.
Yeah.
You could also write as x plus 8 squared.
Mm-hmm.
So here, so you have 9 and 16 both perfect squares. You get that. Or let me set here.
Mm-hmm.
Back here.
Yeah.
Okay. Um, you want to do A times C,
Mm-hmm.
negative 45, 4. Okay, let's find the pair of numbers that make sense for this.
Yeah.
So -1 and 45, no way.
Mm-hmm. Yeah, no.
Not divisible by 2. -3 and 15, we're getting warmer.
Yeah.
45 is not divisible by 4. Negative
No,
5. How about
five
negative
and
5?
nine.
There we go.
Yeah, that's it.
However, that's 3x.
Mm-hmm.
That's x. -5. You get 5/3 and -3.
Mm-hmm.
We solve each of those separately. Again,
Yeah.
zero product property, anything times 0 is 0. So -3 makes that 0, 5/3 makes that 0.
Mm-hmm. All right.
All right. So what do I put up top again?
How 11?
No, that goes to the bottom.
Oh, my bad.
But remember, you do A times C up top.
Yeah.
What's A and C here?
It's a 4x squared and 3.
So that'd be -12.
Yeah.
Okay, give me two numbers that multiply to -12 and add to -11.
-12 and 1.
Good, excellent. Remember, we do our box.
Yeah.
So again, being incredibly consistent here. Give me a sec here. Okay, so let's put 4x squared.
Mm-hmm.
So if you look at the first row, that's x.
Mm-hmm.
Look at this column, that's 4x.
Mm-hmm.
So what do you multiply by 4x? -3
Mm-hmm.
and 1. So those are all the answers that make that work.
Yeah.
So now, from a graphical perspective, if you were to graph this, 'cause I know you've done some graphing, those would be
Oh, we
x.
don't have to graph anymore.
What was that, sorry?
Our teacher came back and we don't have to graph.
Okay, no, but I'm just saying, but like just from an out, what you see off in algebra 2. So these represent the x-intercepts.
Mm-hmm.
And then many times we do modeling with quadratic equations where we want to know where we're touching, whatever we're considering the x-axis, like maybe like you're looking at projectile motion and touching the ground
Yeah.
or something like that.
Mm-hmm.
So these are things that just are skills that we're building as
Mm-hmm.
you progress towards more sophisticated math down the road. Um, let me share something with you really fast, and we'll begin our call. And then I think we're meeting again on Tuesday night at 9 p.m.
Yeah.
And then we'll meet the following Thursday at
And
4,
then
and
on the
then
Monday,
Monday right for when's your final?
Tuesday.
Yeah, the 16th. Okay, good. Yeah, 6 o'clock that Monday night on the 15th. Let's see here. It could be good, but I want something that has a mix of everything.
Hmm.
I know we didn't talk much about college football, but what's your take on the potential playoffs?
Um, I don't think anybody from the SEC can actually win the whole thing, honestly.
City's Big Ten.
Yeah, I'll say honestly, probably Indiana so far. I don't think Ohio State's really like that good. Like they're
But
good, but like
but last year, like all the teams had a bye lost the first round.
yeah, but I think it's different this year because like the new seeding in the playoffs, like it's the four best teams.
Hmm.
Because like last year you had like Boise State as like one of the top seeds and like a Georgia
But
team without their quarterback.
hmm,
And then who's the third seed last year?
I remember.
It was not Arizona State. They're not. May have been actually.
All I know is that West Coast teams, except for Oregon, they're only West Coast team that